Peter, yeah.
Okay, thank you. I mean, isn't what part of the problem that we are still stuck on the idea that we have gravity? Well, let's forget gravity for a moment. Quantum physics, quantum physics and classical physics, and that we're still thinking of one and the other as being two different things that we can't merge. We have h bar going to zero, and that's all we use to bring them together. But there's maybe something a bit higher that encompasses both, and that we're not yet at the stage of the evolution of humanity, whatever that is, uh, to be able to have the concepts to tackle both together as a unity. And that's we have to recognize that sometimes a lot of the concepts, a lot of the language that we find natural to use may not be, we just have to look backwards, and see this discussion. Somebody from 100 years ago walking into the room and hiding and listening thinks, wait a minute, what are they? No, and this would be a top physicist or top scientist. He would be, what are these things they talk, and all these things. So we have to be a bit more flexible with the evolution of our thinking and say, well, it may bring us, with the, I think, let's hope that we got to be surprised by our own thinking instead of looking here and there and hoping to just imagine.
So I mean, we've been trying to unify quantum mechanics and general relativity for more than 100 years. And so we've been trying to explain the mechanism in quantum mechanics for more than 100 years. And what it makes me reflect on was on the time where humanity said, well, the circle is a perfect figure, therefore physics and nature should follow circles. And then they were trying to explain the trajectories of planets following circles, and that didn't work out. Okay, so then there must be a circle within a circle, and that didn't work out. And then, okay, you start using 600 circles to try to do that, which reminds me a little bit, with respect of string theory, that it just gets more and more and more and more complicated. And then comes someone with a different perspective. No, Kepler says that they're not circles, they're ellipses. Boom. So that sort of thing, I think it's time for that. I think that we are stuck in something that we see things in one particular way, and it's time to see them from a different perspective. And to be honest, for some time, because I heard Bomb in a YouTube video, and I was like fascinated, because I think that the right perspective is to turn things around, because we've been trying to say, okay, the most elemental particles that we have are like, I don't know, like say for example atoms, and we have fields like photons and so on. But this is really thinking about breaking the universe into really small pieces and then trying to put them together. And then we're like, oh, we can't explain now the universe from there, from the very little upwards. We can't understand even like what thought is or consciousness or anything like this. But if you turn it around, then you start from the very big, because the universe is unified already, right? The complication is that we, to understand it, we break it up in tiny pieces, and then we can't put the pieces of the puzzle back together. So I really like the approach, and I've been thinking about that kind of very much on my own, and I'm like, oh, there's a community actually thinking on these things, and I'm very happy to be here.
I guess it's already been said, I was going to say, but I guess just to follow up on that point, from the neuroscience perspective, it's kind of well understood now that what we're doing is in the prefrontal cortex on the left hemisphere, which is atomized. It's very good for the economy. It's very good for billions. Like, why this much here and not there? Well, because actually we're in a scientific, military, industrial complex. That's why. Like, it's nothing to do with science. We're shutting down the quantum mechanics at the end of the war, blah 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 blah. So, but coming back of it, when a theory comes, that's new. It's not as if in 1905 it's like adopted, Darwin adopted, right? They were the best theories at the time, right? And then it takes a lot to move that juggernaut and that momentum, but it probably should. Otherwise, everything would be changing and fluxing all the time. But the movement in terms of having this split perspective, and we don't have the tools. It's exactly what the neuroscientists are saying. Right? We've got a right hemisphere and a left hemisphere, and we don't know how to use both of them. And we can get locked into one, which does absolutely break apart. But that's the point. It's there to objectify, right? And you can move things with objects, but you have to hold it. Everything else must remain stationary or whatever. So to me, it's obvious that we're going to get in this loop because we are thinking in a very, very specific, particular, particulate kind of way. Right? But to get in these kind of dynamic models, anything that involves process, anything that involves anything, right? It's going to be hard for not just other physicists, but for the whole world to get this because everyone is locked into a very materialistic framework of me, just me. I'm not connected to anyone. I'm on a lonely little rock. Blah blah blah. So society, everything is a part of this, right? So I wouldn't expect that. I don't, even if it was absolutely correct, and people said, "Oh, that proved that, accept it, get this published." It could take years. But my point is, who cares? Like, if we get it right and we start understanding it, then that starts to filter, right? This is the case all the time. I don't think we should be too disgruntled that people don't accept it. How could they? We have a world at war and climate change, and we're all locked into the left. How could they? So I don't worry about it. I think we should crack on and do the work.
You're going to say something that's closer to what Shannon
Similar. Yeah, I think that was a good. I was going to say similar things above. I think that the classical or Newtonian worldview fails on its own. But even with a consistent worldview, it doesn't work. Partly because, like people have said, it views the world as being atomistic and reducible to individual units, which lead to both the political consequences and also to the sort of the epistemic consequences. But also, I think what is epistemology. I don't think it's a bad thing that knowledge is relative, because that seems to be true to a certain extent. Most of a lot of 20th century philosophy has been the realization that, whilst I would say there's an absolute truth, I think a large part of what we realize is that it's not necessarily accessible to any one human being. The observer does influence what is known, precisely because of their own suppositions or their own operators, or because of their own coordinates or whatever. And so I think the insights from relativity theory and quantum mechanics in that respect aren't sort of a departure from a better worldview. I think they're the mapping out in science of all things that are true outside of science. Even if I think that you can go too far the other way and assume there's nothing or
So I should preface this by saying I'm without question the most ignorant person in the room, coming from a much further background than most of what the discussions are, but I pretend to engage. I also want to preface this by saying I'm very worried that what I'm about to say is going to offend people, and particularly Chris, and having just met and very much liked everybody, then please take what I'm saying in a benevolent way. So I'm a strict highlyist because I have had no teaching in quantum mechanics since stopping it at university and then meeting Basil. So I've detoured through accelerator physics and now primarily cancer and high precision radiotherapy. But one of the things I was fortunate enough to have reasonably regular discussions with him going out walking near where he lived, and the coming back to wave mechanics and the wave function being an encapsulation of ignorance, that the introduction of wave mechanics was because it was the best mathematics that was available, but to describe the evolution of statistical systems. So when you're using wave mechanics, it's because you don't know what the underlying dynamics is. What you do know is the statistical evolution of that system. And so the movement, and I'm not sure if it was Basil that first said the phrase to me, or if it came from Roger Penrose, the idea of geometrizing quantum mechanics rather than quantizing gravity is the way forward. So finding the underlying dynamics, because every time that somebody comes back to the wave function being a fundamental thing, I can feel my gut tighten and think, we're going back to the point where we only have statistical distributions for the evolution of probabilities. And there is an underlying dynamics that actually describes what's going on. Now, the point at which that becomes valid is when the system is too complex to describe in any other way other than statistical evolution. So in talking about cancer, for example, I can totally understand how two particles interact. How you try and simulate how radiotherapy destroys cancer if you're trying to do it in a particle physics way, totally useless because you're not paying any attention to the biology of the system. So there are levels at which phenomenological theories are more important than understanding the fundamentals, but that doesn't mean that you rely on what feels to be underpins quantum mechanics, which is that acceptance that all you have is waves because you don't know what's going underneath, and it's too uncomfortable to think that wave mechanics is not fundamental. I hope that wasn't too offensive.
Not at all. All right, we coming to toward the end of the discussion. Is there a talk or would you like to say something? You're fine? Yes, okay. Okay, so we've had two very intensive days of discussion, and I might be the only one who didn't understand everything, but or then not. But I thought this was very interesting. It was nice beginning, start, and hopefully we can keep up the discussion. I mean, people know that on the June 2:30, there will be the Basil Hiley Memorial Symposium here at UCL. So Peter will probably be sending out information about that.
Yeah, I'll get your list.
Yeah, so that's probably next time where many of us will meet, and also in terms of health at the University of Helsinki, we're also trying to set up this like philosophy of physics, and both in connection with the dynamic universe, but also with the Bohm theory and some of these other things. So here might be, who knows, might be coming here to UCL also help out with the experiments with you. Yes. So we hope that we can have this interaction, and possibly we also will think about it, maybe organizing a meeting in Helsinki, maybe like next year, or somewhere. It could be even in Sweden. We will see, and perhaps continue the discussion. That this is small format. Last year we had a bigger conference in Helsinki, which is also good, but I think maybe in a slightly smaller meeting the discussion. There tends to be more discussion and exchange, and hopefully more understanding. But I don't know. That's for my part. I thank everybody, and then I will give Peter the final word.
There's some sandwiches left.
All right.
Good luck.
Yes.
Okay, there's anybody who drinks
Anybody?
milk,
There's
you can have fresh milk. They couldn't take back even the closed ones. So,
right.
And anybody too late, though, there's nothing in there. So yeah, and then a few biscuits.
Some water.
Do
we drink water?
And for the healthy people from Chris.
Right. So let's make sure
No,
that
please,
we
yeah,
take your
help yourself.
things. Yeah.
Clearing up anyway. Thank you very
Thank
much.
you, everybody, for coming.
Before we go, could you also
please say a very big thank you indeed to Peter and to Parvo and for all the organisations they put in.
Yes.